Hello, welcome back to my recorded classes. Today we are discussing a topic from the course Mathematics for Computing. Uh, Before starting the course, all of you please subscribe my channel for getting more recorded classes. So let's start the first module, that is vectors. So here this module we have two sections. 1.1 vectors and linear combinations and 1.2 length and dot product. Okay, so let's start the first topic, first section, that is vectors and linear combinations. So we will go to the topic. First I am giving some outline to the section 1.1. What are the things we are discussed already here. After that we will go to the exercise questions. So 1.1 vectors and linear combination. So mainly we are concentrating here. We need to define vectors and linear combination. What is the meaning linear combination? Okay, so let's start with some small example, live examples. You can see here, for example, first one, you can see one game, you know the game Angry Bird, correct? So when we are doing this game, okay, we need to be careful about two things. First, when we are stretching this bird and releasing that bird, it will hit on some bird, correct, or some places. So when we are hitting, when we are concentrating this game, we need to think about what direction we need to move this bird, correct, what direction, and same way how much distance we need to travel, correct, for hitting the bird. So two things are we need to be careful. One is about direction, correct, one is about direction, and the second one we can say the distance, or we are telling is magnitude, correct. Now the second one, see, you can see the second picture, you see one person, he is telling 5 meters long, 5 meters long, he is telling about a number, correct, a length. That means only he is telling about the magnitude, correct, only he is telling about the magnitude of the quantity, or 5 meters long, not direction. But in third picture you can see the flight movement means both the direction as well as magnitude, both are important, correct. D means the direction, M means the magnitude. So both the direction and magnitude both are important in the flight movement, because how much distance we need to travel, which direction, correct. And the fourth picture you can see what he is telling, 5 meters east. 5 meters means it is the magnitude, and east means it is the direction, correct. So out of these four pictures, first picture direction and magnitude specifying, second only magnitude, third also, fourth also magnitude and direction is specifying. Now we will come to the point here. Physical quantities we can divide it into two. Okay, what are the two quantities? One is scalars and second one is vectors. Okay, first one is scalar, second one is vector quantity. Now what is the meaning of vector and scalar? Scalar means a physical quantity is having only magnitude, there is no direction. Okay, no any fixed direction is called scalars. Physical quantities having both magnitude and direction, we are calling it as vectors. Okay, you can see on the side. Okay, so in the before example, see, it depends on direction and magnitude. So it is, we can assume like an example for the vector quantity for understanding purpose. Okay, second one is scalar quantity, third one is vector, fourth one also vector. So scalar quantity means a quantity having only magnitude but no direction, correct. For example, distance is a scalar quantity, only we have length 5 meter, 6 meter, like that, correct. Speed is a scalar quantity, speed, how your car is going on, correct, 30 kilometer per hour speed. Okay, so only the length, only the speed it is telling, some quantity, correct, number. Now say mass is a scalar quantity, energy is a scalar quantity. Okay, how much calorie, that is the meaning energy, correct. And density is a scalar quantity. Power means, you know, electric power, watt, how much watt one electric bulb, something like that. Length means only a number, scalar quantity. Area, how much square feet or meter square or centimeter square. And volume is a scalar quantity, how much meter cube or centimeter cube, like that. Okay, time is a scalar quantity, temperature is a scalar quantity, temperature, how much degree Celsius, or okay, that is a scalar quantity, work is a scalar quantity. Now, what are the vector quantities? You can see quantities having both magnitude and direction. So, displacement is a scalar quantity. Displacement means the directed distance, correct? Distance with the direction, that is displacement. Velocity is a vector quantity because velocity means speed with the direction, correct? So, we can say simply like that, velocity is a vector quantity, weight is a vector quantity, acceleration, one more time velocity, that is acceleration. So, it is a vector quantity, force is a vector quantity, impulse, pressure, momentum, gravity, drag, these are all physical quantities are vector quantities. Okay, so some examples already we are discussed, just a brief I am giving the ideas. Now, how we are representing a vector quantity? Okay, how we can represent a vector quantity? Vector quantity always we are representing by using a directed line segment. That means we have a line segment. This point A point we are calling initial point of the vector, and this B point we are calling the terminal point, initial point or starting point. B means the ending point or terminal point of the vector. Now, how we are representing a vector is that first write the initial point A and write the terminal point B. Give a vector notation like this. So, we can call it as vector AB. So, always represented by a directed line segment. That means a line segment with direction. Okay. So, vector AB. Now, if you are using small letters, we can represent like this. Bold letter, okay, bold letter, small letter, vector A. Okay. Without initial and terminal point, you can represent like this, small letter, but bold font with the vector notation, vector A. You can see this line, we are represented vector A. So, either we can represent by initial point and terminal point like this, vector AB, or small letter vector A with the bold font. Now, what is the meaning of magnitude or modulus or length? Okay, length of a vector. Length of a vector means the distance between the initial point and terminal point. That means from A to B, how much distance is there? Okay, how much distance is there from A to B? This is what we are calling the magnitude or length of the vector quantity. Okay, length, or we can say magnitude, or we can say modulus of that vector. I hope you understood that one. And magnitude of a vector always we are representing using the absolute symbol, magnitude of vector AB, like this, magnitude of vector AB. Otherwise, if you are using the small letter vector A, we can use like this, magnitude of vector A. Okay, so magnitude we are representing by using the absolute symbol. I hope you understood that one. Now, we are coming to the third point. Vectors are generally denoted by lowercase, that means small letter, bold face type, bold letters like vector A, vector B, vector C, vector U, vector V, like that. Okay, or we can say bold letter A, B, C, like this, without vector notation also, bold letter, bold font you can use A, B, C, like that. But scalars we are denoted by italic type, small letter A, B, C, without bold. Okay, like this we can represent. So, this is the representation of a vector. Now, we will come to the next point. When we are telling two vectors are equal, when we are telling two vectors are equal vectors. Now, two vectors are said to be equal. Okay, equal. That both vectors having same magnitude and same direction. That means we, for example, this is the first vector, vector A starting point. This is the ending point. Now, this is the second vector, starting point, ending point. Both vectors should have same magnitude. That means from here to here distance, from here to here distance, both should be same, and same direction also. Okay, same direction also. That type of vectors we are calling equal vectors. I hope you understood. Okay, for example, one vector like this, vector A, okay, and another vector like this, vector B. See, both are having same magnitude, same direction. So, we can say equal vector. Now, for example, vector A is this one. How we are writing minus vector A? Minus vector A means the vector takes same magnitude but opposite direction. For example, see, starting from here, ending at here. Okay. Now see what is minus vector A? Minus vector A. That means vector A take in opposite direction. This is the meaning minus vector A. Okay. Same magnitude but direction is opposite. Now minus vector B. See like this. B direction, just to reverse that one. That is what we are calling minus vector B. Okay. Opposite direction. Now we will come to the next point. What is the meaning? Addition of vector and subtraction of vector and multiplication of a vector by a number. For example, see here I can tell you small examples. For example, I have a vector A like this. Okay. And I have a vector B like this. I want to add these two vector A plus vector B. How can we do vector A plus vector B? So what you do is, see this is vector A, same vector I am drawing again. So this is the initial point of the vector, this is the terminal point. Now second vector B vector, we are shifting to the terminal point of this B, the A vector, terminal point of the A vector like this. Same vector we are copy paste here. So this is vector B, correct? And already I told this is vector A. Now how to add these two vectors? Just start from the initial point here and terminal point here. Just to draw a line joining these 2 points. This vector we are calling geometrically A plus B vector. So how to add two vectors geometrically? You can see the starting point here, initial point, and terminal point joining a vector. That is the A plus B vector. I hope you understood. Now when we are going to subtraction of vector, A minus B vector. Okay. So A is same. Now minus B means, as I told, B vector just take in the reverse direction, correct? That is minus of vector B, correct? Now what I am doing, see A vector here same. Now I am just drawing what is minus B vector here. That means B vector draw in the opposite direction, that is minus vector B, correct? Minus vector B here. I hope you understood. Now what we do, just here from starting point up to the ending point, we are just drawing a line, directed line, that is the vector A minus vector B here. So I hope you understood how we are adding two vectors geometrically, how to subtract two vectors geometrically, correct? Now we are going to discuss. So equal vector discussed, addition, subtraction. Now multiplication of a vector by a scalar, by a number. Scalar means a number. For example, okay, I have a vector A here. This is vector A. Now what is the meaning of 2 times vector A? See, a number multiply a vector. A number multiply a vector. So what you do? Take this vector 2 times like this. Okay, 1 time here, 1 time here. So this is the vector 2 times vector A. Okay, I hope you understood. Now same way minus 2 times vector A. If you want minus 2 times vector A, how we do? The same vector in the reverse direction, starting here, correct? This is minus 2 times vector A. Like that, we can multiply a vector with any number. You can form that one. See this picture, this is vector A. You can see this is starting, ending here. Now if you want minus vector A, take in the reverse direction, correct? Same magnitude. 2 times vector A means 2 times we are taking vector A. So this is the geometrical idea behind multiplication of a vector by a scalar, by a number. I hope you understood. Now we are going to the practical questions. Okay. Now see, we discuss how to represent a vector in plane. How to represent a vector in plane. How can we write a vector in plane? And after that we need to study how to write a vector in space. Correct. Now plane means, what is the meaning plane? Plane means it is 2 dimension. Correct. 2 dimension. 2 dimension means we have x-axis and we have y-axis, xy plane. We are telling it as xy plane or 2 dimension. Okay. Now see, in the xy plane, you know this point. This point is center, origin, 0, O point. O means 0, 0. Correct. Now if I am taking a point here, this point is P, xy, because in plane when we are taking a point, it is like x number will be there, y number will be there, like ordered pair. Pair we are telling, 2 number. Pair means 2 number, x, y. Ordered pair means should have one order. First number for x number, second number is y number. So this is 0 point, O point, or this is P point. Now if you are joining if you are drawing a line, okay, starting from O up to P. Okay, this is the vector. You can see one vector I drawn here. Okay, starting from 0. Keep in your mind, starting from 0 up to P. That means initial point is O, final point is P. Vector OP. This vector we are calling a special name. That is, we are calling position vector of the point P. Position vector of the point P with respect to the origin O. Okay, but that means, what is the meaning position vector? Position vector means vector starting from the origin, center, 0, 0 point. Okay, so vector OP is the position vector of the point P with respect to the origin, and this vector we can represent as a ordered pair in component form like this. First x number and y number. Okay, vector OP means, just mark this point, see x and y. X means we are calling x component, y we are calling y component. This is the component form of a vector, vector OP. Okay, so this is ordered pair. XY means it is ordered pair. Ordered pair means x first number, y is the second number, first component, second component, x component, y component. Ordered means should have one order, x should be first, y should be second. Pair means two number. Now this vector OP we can represent like this, ordered pair xy. Otherwise we can represent by matrix like this, x, y. Just represent like a column matrix xy. Okay, so this is the position vector of the point P with respect to the origin O. Okay, vector OP. So position vector means, always keep in your mind, starting with O point. Now 0 point. Now magnitude or length of a vector. How can we calculate the distance from 0 to P? Okay, magnitude of that vector OP we can calculate by using the rule, this one, root of x square plus y square. That means this vector x component square plus y component square, root of x square plus y square. This is the magnitude of the vector, vector OP, position vector, vector OP. I hope you understood. This is the second rule here. Now we will come to the vector joining 2 points. 2 points vector join. Here one point is origin. That is why position vector. Now for example, if you are getting a vector like this, see we have xy axis, x axis, y axis, and here I am taking one point, a point. Point is x1, y1. X number is x1, y number is y1. And I am taking second point here, b, x2, y2. Okay. Now the vector joining, see I am giving the vector notation. It is not starting from the center, correct? Vector starting from the center means we are calling it as position vector. Now here it is not starting from the center, vector AB. So how can we write vector AB, or how can we find the component form of vector AB? Equal. That means vector joining 2 points. Okay, 2 points. Now how we are calculating is ordered pair. Should be ordered pair because xy plane, correct? Ordered pair, second x number minus first x number, x2 minus x1, comma second y number minus first y number. That means y2 minus y1. Okay, this is the vector joining 2 points. Okay, keep in your mind, vector point OP vector means position vector means only xy. But if it is 2 point means x2 minus x1, comma y2 minus y1. So keep in your mind this one, this, okay, important rule. Given points ax1, x2, y2, vector joining 2 point means vector AB equal to x2 minus x1, comma y2 minus y1. And this magnitude means same. What rule we are studied here? Root of x square plus y square. Here x number is x2 minus x1, y number is y2 minus y1. So x2 minus x1 square plus y2 minus y1 square. Now we will do one question, one example here. More question we will do in exercise. Okay. Find the component form. What is the meaning component form? Component form means we need to calculate x component and y component, x, y, correct? And length of the vector with the initial point a 2, 7 and terminal point b 5, 9. Okay, this is the first question. So a vector starting with a 2, 7 and terminal point, ending point of the vector is 5, 9. The point is B, correct? What is the vector? What is vector AB in component form? That is the question. Vector AB in component form. You remember we are studied just before. Okay, for example, this is the first point x1, y1. This is x2 and y2. Now what we are studied vector AB in component form? x2, minus x1, comma y2 minus y1. Apply the number. What is the x2 number there? 5 minus what is x1? 2. And y2 number 9 minus y1 number is 7. So you can get it the answer equal to ordered pair, should be ordered pair 5 minus 2, that means 3. 9 minus 7 means it is 2, 3, 2. This is the vector component form, x component and y component. Okay, the first number is x component, x value, and second is y component, that is y value. Now what is the next question? Find the length of the vector. Length means magnitude of vector AB. Absolute of vector AB equal, what was the rule? Root of x power 2 plus y power 2, correct? Now equal to root of, what is x component? We calculated here. What is the x component here? 3. What is the y component? 2. So 3 power 2 plus 2 power 2. So that you will get from the calculator, it is equal to root of 9 plus 4, that is root 13. This is the magnitude of that vector. I hope you understood that one. Okay. Now we are going to discuss about how to add two vectors, how to subtract, how to multiply two vectors. Okay. For example, you can see the rule first. Let u equal to vector x1 comma y1. V means vector v means x2 y2. Now u plus v vector means first add the x values x1 plus x2 comma y1 plus y2, and k multiply vector u. That means a number multiply a vector means number multiply each numbers in the ordered pair. K multiply x1 comma k multiply y1. Okay, k x number k x1 k comma k y number k y1. Adding means x1 plus x2, x numbers add plus y numbers add. So this is the easier way. Geometrical definition we studied. What is the meaning of addition of vector, subtraction of the vector? This is the practical example when we are getting two vectors in component form, how to add two vectors and how to multiply the vector. For example, see vector u equal to minus 3 comma 4. Vector v equal to 7 comma 6. Okay, find u plus v. First part. Okay, find vector u plus vector v. I can show here. Vector u means minus 3 comma 4 plus vector v means 7 comma 6, correct? Now how to add? As I told, x numbers add. What are the x? Here minus 3, here 7, correct? So minus 3 plus 7, minus 3 plus 7 comma, what are the y number here? 4 and 6. So 4 plus 6. So that you will get the answer equal to minus 3 plus 7 means 4, 4 plus 6 means 10. So this is the u plus v vector. Now the second part, u minus v vector, vector u minus vector v equal to, same we are subtracting. U vector means minus 3 comma 4 plus v vector means 7 comma 6. So when we are subtracting, what value we got? Minus 3 minus 7, correct? Comma 4 minus 6. X numbers subtract, y numbers subtract. So we will get minus 3 minus 7 means minus 10. 4 minus 6 means minus 2. So this is the u minus v vector. Now we can do what is v minus u, 3 multiply u, all this part. First we will do third part. That means 3 times vector u equal to, sorry, before that we need to do v minus u. Third part, vector v minus vector u equal to, what is vector v? 7 comma 6 minus what is vector u? Minus 3 comma 4. Subtraction time, very careful. You will get equal to 7 minus minus 3, 7 plus 3, that is 10. 6 minus 4, that means 2. Subtraction, correct? Now the fourth part of the question. What is the fourth part? 3 times vector u equals, that means 3 times, what is vector u? Minus 3 comma 4, correct? Now how we are multiplying this one? Just multiply with the first number comma multiply with the second number. So we will get 3 multiply minus 3 means minus 9, 3 multiply 4 means 12, correct? Now okay, fifth part of the question, 2 times vector u plus 3 times vector v equal to, that means 2 times what is u? minus 3, comma 4 plus 3 times what is vector v 7, comma 6. Now you can multiply. That means vector 2 times minus 3, minus 6, 2 times 4, 8, plus 3 times 7, 21, plus, comma 3 multiplies 6 means 18. So adding time you will get 15, comma 26, because minus 6 plus 21, 15, and 8 plus 18, 26. Now we will go to the sixth part of the question. We need to calculate what is absolute u vector and magnitude of vector v and magnitude of vector 3u. These are the question in sixth part. So first we will do what is magnitude of vector u. What is the rule we are studied? Magnitude root of x power 2 plus y power 2. So root of, you can see u vector. U vector means minus 3, comma 4. So x number is minus 3 power 2 plus y number is 4 power 2. Correct? So you will get equal to 5 from the calculator. 9 plus 16 root means root 25 is 5. Same way we can do magnitude of vector v. That means root of x square plus y square. V vector means 7 and 6. So 7 power 2 plus 6 power 2. So we will get equal to 7 power 2 means 49. 6 power 2 means 36. So totally we will get root of 85. Hope you understood. Now magnitude of 3 times vector u. Root of 3 times vector u we are calculated here. What is 3 times vector u? Minus 9 and 12. So x number is minus 9 power 2 plus 12 power 2. Y number is 12. 12 power 2. That means we will get root 225 or equal to 15 from the calculator. Okay, equal to 15. So this is the magnitude of 3 times vector u. I hope you understood this question. Now we will discuss some small points here, small notes. Now you know in xy plane what is the center? I told 0, 0, correct? This point we are calling 0 vector notation, 0 vector. That is calling 0 vector in the plane, xy plane. Okay. Now the 0 vector, always the length will be 0. Okay. The 0 vector means nothing, one point, correct? In xy plane, this is the 0 point, O point, 0, comma 0, correct? So distance is 0, length is 0, and 0 vector is the only vector in the xy plane. There is no specific direction because single point, any direction, correct? Specific direction, no specific direction. It is 0 vector. Now another important point, we need to be standard unit vector. This is very important. Standard unit vector. Standard unit vector means, for example, you can see x-axis and y-axis. Okay. Now x-axis, if I am taking a point 1, y-axis also take the point 1. Okay. Now what is this 1 actually? x1 means x1, y0, ordered pair 1, 0. So this vector we are calling a special name, vector I. Standard vector I equal to 1, 0. See, vector I equal to 1, 0. Now same y-axis, when we are taking a point 1, what is that point? x0, y1, correct? So that vector starting from center, correct? Origin. That vector we are calling a name vector j. Okay, vector j equal to 0, 1. These are the standard unit vectors in the xy plane. Two vectors, okay, vector I and vector j. So this is very important. You can just note standard unit vector in the xy plane. Vector I 1, 0, vector j 0, 1. Hope you understood. Now we will go to in space. The same idea we are discussing in space now. Okay, space. Okay, space means, what is the meaning? Space, 3 dimension, correct? 3 dimension. That means we have 3 axes. X-axis is there. Here you can see x-axis, and here see y-axis, and here see the z-axis. 3 dimension figure. Okay. So if you are taking a point in space, how many number will be there? X, y, z. 3 number. Correct. We have x number, y number, and z number. X number will be there, y number will be there, z number will be there. Plane means only xy. Space means x, y, and z. Okay. We are calling this as triple. Okay, in plane we discussed pair, but here triple or triad, ordered triple. Okay, order should be there, x first number, y second number, z third number. Now, when we are taking a point center here, O point. O point is what? 0, 0, 0 because x 0, y 0, z 0. Now, if you are taking a point P here, x, y, z, and we just join a vector like this, starting from O up to P. So, vector O, P. O is the starting point, P is the terminal point, ending point. This vector we are calling position vector in the space, same like in the plane what we discussed. So, vector OP equal to, how we are representing in component ordered triple, 3 number. How 3 number? X, Y and Z, correct? Otherwise, we are representing matrix notation, column matrix X, Y and Z. Okay, like this, vector OP equal to. So, this is what we are calling position vector in the space, starting from O point, okay, 0 point, that is the position vector. X called X component, Y we are calling Y component, and Z we are calling Z component, okay. Now, what is the magnitude or length of a vector? Magnitude of a vector starting from O up to P. What is the distance? What is the magnitude of vector OP? In plane, what we are studied? Root of x square plus y square. Here one more component extra will come. So, root of x square plus y square plus z square. That is the magnitude of the vector OP. So, you can see here magnitude or length means, okay, root of x square plus y square plus z square. Now, same way vector joining 2 points. For example, A is 1 point, x1, y1, z1 because 3 number, correct? Now, the vector ending point B. B means x2, y2, z2. Okay. Now, what is the vector joining 2 points? Vector AB equal to. Okay. Not starting from the center. As I told you, if you starting with the center means position vector. It is vector joining 2 points. So, vector joining 2 point vector AB equal to x2 minus x1. Same like in the plane. X2 minus x1, y2 minus y1, comma. Now, in the plane means one more component will come, z2 minus z1. So, whatever we are studying in plane, just extend that into the space. Okay, x2 minus x1, y2 minus y1, z2 minus y1. Okay, so this is the vector joining 2 point in the space. So, vector AB you can see here x2 minus x1, y2 minus y1 and z2 minus z1. Now, we will go to one question here. Example 3. Find the component form or length of a vector with initial point. A point is 7, 4, 5 and B point, terminal point. B point is 4, 8, 3. Okay. So, first point it is given x1, y1, z1. Second point x2, y2, z2. X value, y value, z value, like that. Now, what we need to do our question? Component form of the vector. Component form means we need to find x, y, z of that vector. Vector AB, what is the x component? Vector AB, what is the y component? Vector AB, what is the z component? Z value, correct? So, what was the rule we are studied? Vector AB equal x2 minus x1, comma y2 minus y1, comma z2 minus z1, correct? Just apply the number. What is x2? X2 means 4 minus 7, y2 minus y1, 8 minus 4, z2 minus z1, 3 minus 5, correct? I hope you understood that one. Okay, how to do that one. Now, what is the answer we are getting? Equal to 4 minus 7 means minus 3, 8 minus 4, 4, 3 minus 5, minus 2. This is the component form. Component form vector AB, first component x, second component y, third component z. Now, what is the second question? Find the length of the vector, length or magnitude. So, magnitude of AB, vector AB equal to, what is the rule we are studied? Root of x square plus y square plus z square, correct? That means root of AB vector x component minus 3, just now we calculated, power 2 plus y means 4 power 2 plus z means minus 2 power 2. So that you will get the number root 29. I hope you understood this question in space. Okay, now we will go to how to add two vectors, subtract two vector, multiply number with vector in space. You can see, for example, we have a vector x1, y1, z1, vector v, x2, y2, z2. Then u plus v vector means if we add two vector, x components add, y components add, z components add, x1 plus x2, comma y1 plus y2, comma z1 plus z2. And k multiply u, a number multiply a vector means k multiply x1, k multiply y1, k multiply z1. We will go one example. For example, vector u equal to 2 minus 1, 3. Vector v equal to 3, 5, 1. Find u plus v first. Vector u plus vector v equal to, what is u? 2 minus 1, 3. Plus, what is vector v? 3, 5 and 1. Now add the numbers, same like in the plane. First numbers add. 2 plus 3. Hope you understood. First x number here, x number here, add. Okay. So we will get 2 plus 3, that means 5. Minus 1 plus 5, 4. 3 plus 1, 4. 5, 4, 4. That is the a plus u plus v vector. Now second question, what is vector u minus vector v equal? Okay, vector u means 2 minus 1, 3. Minus, subtract, okay. Vector v means 3, 5 and 1. So what answer we got? Just to subtract the first number first. 2 minus 3. 2 minus 3 means, okay, same like subtraction, minus 1. Minus 1 minus 5, minus 6. Okay, and 3 minus 1, that is 2. So this is the a minus v, u minus v vector. Hope you understood. Now the third part of the question. We will do 2 times vector u plus 3 times vector v equal to, okay, that means 2 times, what is vector u? 2 minus 1, 3, plus 3 times, what is vector v? That means 3, 5 and 1. Now you know how to multiply that number 2 inside. Multiply 2 with here, here and here. Same here also, multiply 2 inside. So you will get 2 multiply 2, 4, minus 2, 2 multiply 3, 6, plus 3 multiply 3, 9, 3 multiply 5, 15, 3 multiply 1, 3. Now when we are adding these two, you will get 13, 13, 9. Correct? First number add. 4 plus 9, 13. Minus 2 plus 15, 13. 6 plus 3, 9. So this is the value of that vector 2u plus 3v. Now we will go to the fourth part of the question. That means magnitude of vector u. Magnitude of vector u. That is the fourth part of the question. What is magnitude of a vector? We studied root of x power 2 plus y power 2 plus z power 2. Now you know what is u vector. What is the u vector given? 2 minus 1, 3. So what is the magnitude root of x power 2? X means 2. Power 2 plus y minus 1 power 2 plus z 3 power 2. So you can check by calculator. It is 4 plus 1 plus 9 root. That means root 14. That is the magnitude of vector u. I hope you understood how to add, subtract and multiply in space. Now there is some notes, same like in the plane. The vector in the space, 0 vector, 0, 0, 0, x number 0, y number 0, z number 0. This is called 0 vector in the space, vector 0, 0 vector notation. And this vector 0 vector length should be 0 and there is no specific direction for the 0 vector. Now what are the standard unit vectors in the space? This is what important. What are the standard unit vectors in the space? Okay, so we can see we have in space x axis is there, y axis is there. This is x, this is y axis and this is z axis, correct? Now when we are taking the number, x axis number 1, y axis 1, z axis 1, standard unit vector, one vector. Okay, so this vector What is this vector? 1 means, what is the meaning? x1, y0, z0. This is what we are calling vector I. And here, okay, x0, y1, z0. This is we are calling vector j. And here, if you are taking a vector here, what is this point? x0, y0, but z1. This is we are calling vector k. So what are the standard unit vectors in the xyz space, 3 dimension? Vector I means 1, 0, 0. Vector j means 0, 1, 0. Vector k means 0, 0, 1. This we are calling the standard unit vectors in the space. I hope you understood. Now, there are some properties here. You can read this one. U plus v and v plus u always same, commutative. And associative property, u plus v plus w means u plus v plus w same. And additive identity, 0 vector and u vector, when we are adding, always we are getting same vector, vector u. U vector and minus u vector, when you are adding, you will get a 0 vector. And when we are multiplying 0 with a vector, always answer with a 0 vector. And same with c multiply k multiply u equals c k multiply u vector. And the distributive property here also we can say c multiply vector u plus vector v means c multiply vector u and c multiply vector v. That is the distributive property. Now we will go to this one, linear combination. What is the meaning of linear combination of vectors? Okay, how to combine the vectors? What is the linear combination? For example, we have a vector v is said to be a linear combination of u1, u2, u3 and un. When we are telling there exist some scalars k1, k2, k3 up to kn, such that vector v equal to k1 multiply vector u1, k2 multiply vector u2 and k3 multiply vector u3 up to kn multiply vector un. For example, see in plane, I am just taking a vector v and another two vector u1 and vector u2. When we are telling this vector is a linear combination of u1 and u2, okay, in the plane, we can take two scalar numbers. Scalar number I am taking x and y, okay, scalar number x and y. So vector v is a linear combination of u1 and u2 means a scalar multiply vector u1, a number multiply vector u1 plus another scalar, another number y multiply vector u2. What answer it should be? Vector v. X number multiply u1 vector plus number multiply u2 vector, you should get vector v. Then we are telling v is a linear combination of u1 and u2. Now same in space, for example, space, if I am taking the vector v and another vectors u1, u2 and u3 vector, 3 vectors, any 3 vectors, okay. Now I am taking the scalars x, y and z. These 3 are scalars, for example, okay. Instead of k1, k2, k3, I am taking x, y, z like. So when we are telling vector v is a linear combination of u1, u2, u3, just calculate x multiply u1 vector plus y multiply vector u2 plus z multiply vector u3. You will get same as vector v. If you are getting same vector v, then vector v is a linear combination of u1, u2 and u3. Okay. So finding this number, this is the important thing. Okay. If you want to write the linear combination, we need to get this number x and y, x, y and z here. Okay. If this number we can find, then we can write the linear combination. Otherwise, linear combination not exist. Okay. So this is the idea here. Combine the vector, adding, multiply and add. So like this. This is the general. Vector v equal to k1 u1, k2 u2 up to the last. So at least you can just remember these two. Plane, how can we write the linear combination? Space, how can we write the linear combination? Now there is some point here we need to memorize or we need to know. It is easy. Two vectors are said to be collinear vectors. Two vectors are said to be collinear. Collinear means two vectors are coming on the same line. Okay. For example, see, I have a vector here. This is vector u, correct? This is vector v. See, both are coming on the same line. This is the meaning collinear vectors. Okay, they are lying on the same line, collinear vectors. So when we are telling two vectors are collinear is, this is the condition. One vector equal to a number multiply another vector. One vector equal to a number multiply another vector. Okay, that means vector u equal to k multiply vector v. So this is the condition. One of the vector, either vector v or vector u. So for example, vector u equal to a number, k is a number, multiply the second vector. K multiply second vector, if you got first vector, then we are telling that two vectors are collinear vectors. Okay, I hope you understood that one. Okay, so one vector equal to a scalar multiple of second vector. Number multiply second vector means we are telling collinear vectors. Now another important point, see, if you are taking the vectors from plane and space, for example plane first, okay, then we need to discuss about space. Now we discussed what are the standard unit vector. Standard unit vectors, correct, in plane and space. What are the standard unit vector? Vector I equal to 1 0, vector j equal to 0 and 1. What are the unit vectors in space? Vector I equal to 1 0 0, vector j equal to 0 1 0, and vector k equal to 0 0 and 1, correct. Now if you are taking any vectors in the plane, for example 6 8, okay, any other vectors in the plane, we can write this vector as a linear combination of standard unit vector. That means how to write this vector in terms of I and j. It is easy. What is the x component here? 6. So 6 multiply x direction unit vector, that is I, plus second number y component 8, multiply the standard unit vector in y direction, that is vector j. So this is the representation of a vector in terms of standard unit vector. Okay, so any vector we can write like this: 6 8 equal to 6i plus 8j. For example 7 9 is a vector in plane. How to write that one? 7 multiply I, x number multiply I, y number multiply j. Okay, all of you careful that one. Same way space also. For example, if I am taking a number from the space means 3 number. For example 2 5 8. Okay, 3 numbers. How to write in standard unit vector? First number multiply I component multiply standard unit vector in x direction I. Second number 5 multiply the standard unit vector in y direction vector j, plus third one 8 multiply vector k. This is the representation in terms of standard unit vector. Okay, so I hope you understood that one. So this is the idea here mentioned, how to write a vector in plane as a linear combination of standard unit vectors in plane and standard unit vectors in the space. Okay, I hope you understood these definitions. Now we will do some example here. Example 5. Write each of the following vectors. Write each of the following vectors as a linear combination of standard unit vector. Just now we discussed it. That means this vector we need to write in the unit vector, standard unit vector. For example here 4 9. How to write? 4 times I is the unit vector in x direction, plus 9 multiply j is the unit vector in y direction. 4i plus 9j. X multiply I plus y multiply j. Okay, where I means what is the I vector? 1 0, because in plane. Vector j means 0 1, plane vectors. Same like second example. What is the answer? Equals 3x number I plus minus 5 times j. You can write like minus 5j. Okay, I means 1 0, j means 0 1. Now in space one vector 2 5 7. How to write? 2 times I vector plus 5 times j vector plus 7 times k vector, correct? Where I is, vector I means 1 0 0 and vector j means 0 1 0 and vector k means 0 0 and 1. Okay, So I hope you understood how to write a vector as a linear combination of standard unit vectors. Now here, this one, first number 7 multiply I minus 2 times vector j minus 6 times vector k, where I and j and k we need to mention because plane and space it is different. So we need to write what is I, what is j and what is k. So I hope you understood the ideas in the first section 1.1, correct? Now we will go to the questions, exercise questions one by one from all these ideas. Okay. Yeah, before that we will do one example, this question, then we will go to exercise after. For example, let vector u equal to 2, 3, 1, vector v equal to 0, 0, 2, w equal to 4, 0, 1. Find the linear combination, that is the question. Linear combination. What linear combination we need to find? Vector u plus 2 times vector v plus 3 times vector w. What is this value? This linear combination we need to calculate. I hope you know that one. See, vector u means what is that? 2, 3, 1 plus 2 times what is vector v? 0, 0 and 2 plus 3 times what is vector w? 4, 0 and 1 equal 2, 3, 1 plus, you know how to multiply 2 times this vector, correct? Each number multiply with outside number. So we will get 2 multiply 0, 2 multiply 0, 2 multiply 2 plus 3 multiply 4, 12, 0 and 3. Now add all these numbers equal vector. First numbers add 2 plus 0 plus 12, 14, 3 plus 0 plus 0, 3, 1 plus 4 plus 3, 5 plus 3 is 8. So this is the linear combination u plus 2v plus 3w. Clear? Okay. Now we will go to the examples, exercise questions from these ideas. Exercise 1.1, first question. Classify, okay, the measures scalars or vector. Okay, which of the following are scalars and which of the quantities are vector quantities? This is the first question, scalars and vectors. For example, the first one, 5 second. 5 second means it is time, correct? Time means which quantity? It is a scalar quantity, correct? Now 100 centimeter cube. What is that 100 centimeter cube? Before that you can see. For example, centimeter. Centimeter means what? Length, correct? Length means it is scalar quantity. Now if you are taking, for example, like this rectangle, what is the area it is calculating? Length multiply width, correct? Length multiply width. So centimeter square. For example, this is centimeter, this is in centimeter, then centimeter square or meter square or feet square, like that. So this is area. Area means always a scalar quantity. Centimeter square. Okay. Now same. For example, if you are taking a cube like this. Okay. If you are taking a cube like this. Okay. Now in the cube, this is centimeter. For example, this is centimeter, this is centimeter. So what will be the volume? Volume means centimeter cube. Centimeter cube. Okay. So volume. Volume also a scalar quantity. Okay. So keep in your mind, centimeter or meter, whatever the unit. So length, area, and square means area. Cube means volume. So we can go to this one. 100 centimeter cube. Cube means volume. Volume means it is a scalar quantity. Now 40 meter per second towards north. 40 meter per second always when we are telling speed or velocity, correct? Now speed with the direction we are calling velocity. So here 40 meter per second means speed, towards north means direction. So it is velocity. Velocity is a vector quantity. Now 20 meter per second square. Meter per second square means it is the unit of acceleration. So 20 meter per second square means it is acceleration. Acceleration means it is a vector quantity. Correct? Now again 30 kilometer per hour, 30 kilometer per hour. In a car meter, you can see your speed 30 kilometer per hour, 120 kilometer per hour. Like, so 30 kilometer per hour means it is speed. There is no direction here. So speed means it is scalar quantity. Okay. Now 40 degrees Celsius. Degree Celsius means temperature. Temperature is a scalar quantity. 40 watt. Watt means is of power. One electric bulb, how much watt? 40 something different. 40 watt. So 40 watt is a power unit. Power means it is a scalar quantity. Now 10 Newton. Newton is the unit of force, correct? Force means it is a vector quantity. So these are the classification of this example. Whichever, okay, what are the quantities are vector and scalars. Now we will go to the second question. Find the component form and length of the vector. Find the component form and length of the vector. Initial point, terminal points are given. Component form we discussed. We need to calculate x value, y value. Length means we need to calculate the magnitude of v or absolute v, length of the vector. So first we do the component form. Okay. So starting point A, minus 4, 6. That vector ending point B, 9 and 5. Okay. So what is the component form? x1, y1, x2, y2. Correct. Now what is the component form we studied? Vector AB equals x2 minus x1, y2 minus y1. So what is x2 minus x1? x2 number is 9 minus x1 number is minus 4. 9 plus 4. y2 minus y1. 5 minus 6. So what answer you got? Okay, you can check it. 9 plus 4, that is 13. 5 minus 6 means minus 1. Correct? Now we will go to the second question. What is the magnitude, length? Magnitude of vector AB equals, what is the rule? Magnitude of vector AB is root of x square plus y square. X means the x component. What is the x component here and y component? X component of vector AB, that is 13. Y component of vector AB is minus 1. So how to calculate? Root of 13 x component square plus y component is minus 1 power 2. Correct? Now you can check that number. 13 power 2, that is 169. 169 plus 1. Correct? So root of 170, whatever the number. Okay, root of 170. Now we will go to the second question. That is P equal to 4, 3, Q equal to minus 1, 1 comma minus 7. Vector P, Q, correct? P is 4, 3. Q is 1 minus 7. So this is x1, y1, x2, y2. So vector PQ we need to calculate. That is x2 minus x1, comma y2 minus y1. What is x2? x2 is, we can get it, 1 minus 4, comma y2 minus y1, minus 7, minus 3. So we will get the answer. Ordered pair. 1 minus 4 means minus 3 and minus 7 minus 3 means minus 10. Hope you understood. Now we can calculate absolute of vector PQ equals root of, same rule, x square plus y square. X square means minus 3 square plus y square, that is minus 10 square. So minus 3 square means 9. 10 square means 100. So what is the number? Root of 109. Hope you understood these questions. Now question number 2, C part. Same model in 3D, in space. For example, A is the number 0, 7, 2 and B 9, 1, 5. Find the component form. Component form means x, y, z we need to calculate because in space. And after that magnitude of that vector. Correct? So here x1 is 0, y1 is 7, z1 is 2. x1 9, x2 9, y2 1, z2 5. So we will go to the calculation. Vector AB equals, so what was the idea? x2 minus x1, y2 minus y1, z2 minus z1, correct? Apply the number. What is x2 minus x1? 9 minus 0. y2 minus y1, 1 minus 7. z2 minus z1, 5 minus 2. So what will be the answer? 9 minus 0, 9. 1 minus 7, minus 6. 5 minus 2, 3. Okay. So in that question, what is the x component? 9. Y component? Minus 6. Z component? That is 3. Correct? Now we need to calculate what is magnitude of vector AB equals. Magnitude of the vector AB equals. So what was the rule? Root of, in space means x power 2 plus y power 2 plus z power 2. Correct? So equal root of, what is the x number? 9 power 2 plus y means minus 6 power 2 plus z means 3 power 2. You can check this number in your calculator. 9 power 2 means 81. Correct? 6 power 2 means 36. 3 power 2 means 9. So root of 126. We will get root of 126. I hope it is clear to you. 3 root 14, otherwise 11.2 approximately. 11.2. Okay. Now go to the next question. PQ. P is given, Q is given. So in P, x1 number is minus 8, y1 4, z1 3, x2 2, y2 3, z2 2. So we need to calculate what is vector PQ equals x2 minus x1, 2 minus minus 8, y2 minus y1, 3 minus 4, z2 minus z1, 2 minus 3. Rule is same before we wrote. So 2 plus 8 means 10. 3 minus 4 means minus 1. 2 minus 3 means minus 1. Clear? Now absolute of the vector PQ. Absolute of vector PQ equals root of x component 10 power 2 plus y component minus 1 power 2 plus z component minus 1 power 2. So we can check 100, 10 square is 100 plus 1 power 2 minus 1 power 2 is plus 1 minus 1 power 2 is 1. So root 102 is the answer. Hope you understood this question, component form and length, correct? Okay, now the third question. Find u plus v, 2u minus v, 2u plus 3v, absolute v, absolute u, absolute 3u. U vector is given and v vector is given. So we will do one by one. First part of the question. U plus v vector we need to calculate. What is u vector? 4, 2 plus what is v vector? Minus 7, 9. You know how to add these two. X number add 4 plus minus 7, correct? 4 plus minus 7, that means minus 3. Now 2 plus 9, that is 11. So we will go to u plus v. Now we will go to the calculation. U minus vector v. What is u minus v? U means 4, 2. Minus v means minus 7 and 9. So what we will get it? 4 minus minus 7. That means 4 plus 7. 11. 2 minus 9. Correct? Minus 7. Now what is the third question? We can calculate the third one. We can do 2 vector u plus 3 times vector v. That means 2 times what is vector u? 4, 2 plus 3 times what is vector v? Minus 7, 9. You know how to multiply that one, correct? Multiply here, same multiply here and multiply here. So what we are getting equals 2 multiply 4, 8. 2 multiply 2, 4. Plus 3 multiply minus 7, minus 21. 9 multiply 3, 27. Now add that to equal the vector. So first one 8 plus minus 21, minus 13. Then 4 plus 27, correct? 31. So this is the vector 2u plus 3v. Now absolute of u, absolute of v, that question we need to do now. Okay, so first we do what is absolute of vector u equal. What was the rule? Root of, correct? Here the point is in plane. Root of x square plus y square. So what is the x value in vector u? Equal 4 power 2 plus 2 power 2, correct? Because you know x number 4, y number is 2. So you can check by calculator. 4 power 2 means 16, 2 power 2 means 4. So root 20. Now absolute of vector v equal, okay, again root of x square plus y square. X means minus 7 power 2, y means 9 power 2. You can check the number. 7 power 2 means 49 plus 9 power 2 means 81. So root 130. Point number also you can write. Now absolute 3 times vector u. This is the next one. 3 times vector u. So first we can calculate what is 3 times of vector u. We can do simply like this. So 3 times vector u means 4, 2. So 3 multiply 4, 2 means 3 multiply 4, 12, comma 3 multiply 2 is 6. So we can do root of 12 power 2 plus 6 power 2, correct? You know what is 12 power 2? 144. So root 144 plus 6 power 2 means 36. So finally we will get the answer 144 plus 36, 180. Root 180, correct? You can write the point number also like 13.4 approximately. Okay, 13.4. Hope you understood this question, what to do. Okay, now question 232. Question number 3, second part. Now you can practice, okay, as much you want. So vector u plus v first calculate. Vector u plus vector v equal. What is vector u? Minus 2, minus 1, 0. Plus minus 1, 8 and 2. So add the number first. Minus 2 plus minus 1, minus 3. Minus 1 plus 8, 7. 0 plus 2, that is 2. Correct? Now vector u minus v next. Vector u minus vector v equal. What is vector u? Minus 2, minus 1, 0. Minus vector v means minus 1, 8, 2. So when we are getting subtracting minus 2 minus minus 1, correct? Minus 2 minus minus 1, that is minus 2 plus 1, minus 1. Minus 1 minus 8, minus 9. 0 minus 2, minus 2. Now 2 times u vector plus 3 times v vector. So we can write 2 times what is the u vector? Minus 2, minus 1, 0. Plus 3 times v vector, minus 1, 8 and 2. Simplify first. 2 multiply minus 2, minus 4. 2 multiply minus 1, minus 2. 2 multiply 0, 0. Plus 3 multiply minus 1, minus 3. 3 multiply 8, 24. 3 multiply 2, 6. Now you can add these two vectors. You will get the number. For example, minus 2 plus minus 3. Sorry, minus 4 plus minus 3, minus 7. Minus 2 plus 24, that means 22. Then minus 0 plus 6, that is 6. So this is the 2u plus 3v. Now we will go to what is vector u magnitude and what is vector v magnitude, and what is vector 3u magnitude, correct? So first we will do u magnitude, root of x square plus y square plus z square, correct? Because the point in space. So u vector x component, what is the u vector x component? Root of minus 2 power 2 plus y component minus 1 power 2 plus 0 power 2. That means root of 4, 2 power 2 means 4, plus minus 1 power 2 means 1, 0 power 2 means 0, so root 5. Now we calculate what is the absolute of v. So root of same x square plus y square plus z square. Here the vector minus 1, 8 to 2. So minus 1 power 2 plus 8 power 2 plus 2 power 2. Okay, we can check the calculator. Minus 1 power 2 means plus 1. 8 power 2 means 64. 2 power 2 means 4. So you will get root 69. Now magnitude of 3 times vector u, correct? So first check 3 times of vector u. 3 times, what is vector u? Minus 2, minus 1, 0. So you can multiply 3 minus 2, multiply minus 2, minus 6, minus 3, 0. So minus 6 power 2 plus minus 3 power 2 plus 0 power 2. That means 6 minus 6 power 2 means 36. 3 power 2 means 9. So root 45. Root of 45. Can write the point number also. So root 45. Hope you understood this type of questions. Now go to the next one. Question number 4. Write the following vectors as a linear combination of standard unit vector. You know what are the standard unit vectors, correct? Vector I means 1, 0. Vector j means 0, 1. Standard unit vectors in plane. Space, what are the unit vector? Vector I equals 1, 0, 0. Vector j means 0, 1, 0. And vector k means 0, 0, 1. So we need to write these vectors as a linear combination of standard unit vectors. That means these vectors. For example, first one, minus 2, 6. X component is minus 2, y component is 6. So x component, that is minus 2, multiply I vector, plus y component, that is 6, multiply vector j. Where vector I means 1, 0, vector j means 0, 1. Don't forget to write that vectors. Okay, we need to know space vector and plane vectors. Now second one, 9, 12. So 9 multiply I vector plus 12 multiply j vector. It is easy to write the vector in standard unit vectors. Now in space one vector, 1 minus 5, 4. 1 minus 5, 4. So 1 multiply I vector minus, plus minus means minus, 5 multiply j vector plus 4 multiply k vector. Where I vector means 1, 0, 0 and j vector means 0, 1, 0 and k vector means 0, 0, 1. Okay, we need to mention that one. Now third one, last one, 8 multiply I plus minus 2 multiply j minus 3 times vector k. So this is the vector representation in standard unit vectors. I hope you understood this one. Okay, now let me go to the next question. Question number 5. Find the linear combination of the following. Find the linear combination. We need to calculate what is the linear combination. Not writing standard unit vector. Just calculate the linear combination. Okay. U means 1 minus 1. V means 1, 1. What linear combination we need to calculate? This one. This one equal to how much? That is the question. W equals 2 times vector u plus 3 times vector v. That means 2 times, what is vector u? 1 minus 1. Plus 3 times vector v means 1, 1. You know how to multiply. 2 multiply 1, 2. 2 multiply minus 1, minus 2. Plus 3 multiply 1, 3. 3 multiply 1, 3. After that add, first number add. First number x component 2, 2 plus 3, 5. Minus 2 plus 3, that is 1. So this is the linear combination 2u plus 3v or w vector. Same one more model is here. W vector equals minus vector u minus 2 times vector v. So minus, what is vector u? Minus 2 comma 1 minus 2 times vector v, 2 comma minus 2. You can expand that one. You can distribute this to here. So what will be the answer getting? Equals minus multiply minus 2 plus 2, minus multiply 1 minus 1, minus, I am here distributing only that 2. You can distribute minus 2 also. So 2 multiply 2, 4, 2 multiply minus 2, minus 4. Now subtract these two vectors. What answer you can get it? 2 minus 4, minus 2. Minus 1 minus minus 4, that is minus 1 plus 4, that is 3. So this is the linear combination minus u minus 2v. I hope you understood. Go to the next one. Question number 5, same model. Question number 5. Okay. Find the linear combination. Again, what linear combination? W equals 3u minus 5v, correct? So 3 times u vector, 2, 4, minus 5, minus 5 times v vector, 1, minus 6, 9. So you will get 3 multiply 2, 6, 3 multiply 4, 12, 3 multiply minus 5, minus 15, minus 5 multiply 1, 5, okay, 5 multiply 6, minus 30, and 5 multiply 9, 45. This minus I am not distributed. If you want, you can do minus also inside, then you can add later. Now what answer we will get? Equal this vector minus this vector, correct? So first one 6 minus 5, so 1. Now next one 12 minus minus 30, that means 12 plus 30, 42. Then minus 15 minus 45, okay, consider that minus correctly. So minus 15 minus 45, that means minus 60. So this is the linear combination 3u minus 5v. Okay, now we will go to this linear combination. We need to calculate this. This is equal to how much? 2 times vector u plus 3 times vector v minus 5 times vector w equals. So 2 times, what is vector u? 2 minus 7, 1, plus 3 times, what is vector v? Minus 3, 0, 4, minus 5 times vector w, that is 0, 5, minus 8. So calculate that vector equals, first multiply 2 to the vector. So 2 multiply 2, 4. 2 multiply minus 7, minus 14. 2 multiply 1, 2. Plus 3 multiply minus 3, minus 9. 3 multiply 0, 0. 3 multiply 4, 12. Minus 5 multiply 0, 0. 5 multiply 5, 25. 5 multiply minus 8, minus 40. Now you can write in single vector. First two vector add and third vector subtract. So 4 plus minus 9 plus 0, minus 5. Second one minus 14 plus 0, minus 25, correct? Minus 39. Third one 2 plus 12, 2 plus 12 minus minus 40, so plus 40, 54. So this is the linear combination of that vectors. Hope you understood. Now we will go to the next one. Find the values of x and y. Find the values of x and y where x3, vector x3 equal to 2 comma 2x x plus y. That means one vector x3 should be equal to the second vector 2x plus y. Correct? You know, two vectors are equal, we studied. When we are telling two vectors are equal, vector having same magnitude, same direction. So for example here, this is vector first one x3, correct, and 2x plus y. So this is equal. You can see this equal to symbol. Equal means first number should be equal, second number should be equal. That is the meaning equal vectors. Okay. Now what is the first number? X. What is the first number there? 2. So what is the first answer? X equal to 2. Okay. Now second one 3 equal x plus y. 3 equal x plus y. That means 3 equal, x number 2 plus y. So what will be the y value? 2 take to the next side. 3 minus 2. So y equal 3 minus 2 means 1. So just the idea equal vector. Okay. Equal vector. When we are telling two vectors are equal. This is the idea in this question. So same magnitude, same direction, or components should be same. Hope it is clear to you. Now we are going to the 7th question. This is what the important question, this section. Write the vector. Write the vector as a linear combination of the vectors u1, u2 and u3. Write the vector v as a linear combination of the vector u1, u2 and u3. Okay. We discussed when we are telling linear combination of vectors in the plane, linear combination of the vectors in space. Remember this idea. Plane means what is the linear combination we studied? Vector v equals x multiply vector u1 plus y multiply vector u2. In space means how we are writing linear combination? Vector v equals x multiply vector u1 plus y multiply vector u2 plus z multiply vector u3. Correct? So we can go to this question using that one. Here the vectors in this space, 3 numbers are there. Correct? So linear combination means how to write the linear combination? Vector v as in u1, u2, u3. Vector v equal x multiply vector u1 plus y multiply vector u2 plus z multiply vector u3. Okay, this is the linear combination of the vectors u1, u2, u3. Okay, vector v in linear combination of u1, u2, u3. Now here what is our aim is, we need to calculate what is x, what is y, what is z. If you are getting these 3 number, linear combination exists. We can write the linear combination. Otherwise there is no linear combination. So we can check this one. First apply vector v value. What is vector v? 1 minus 2, 5 equal x. We need to calculate u1 vector 1 comma 1 comma 1 plus y u2 vector 1, 2 and 3 plus z multiply what is u3 2 minus 1 and 1. Correct? Just apply there. That means 1 comma 2 comma 5 minus 2 comma 5 equals x multiplied to the bracket or vector. First one, second, third. Correct? So we can write x multiply 1 x plus y multiply 1 means y. Y multiply 2 means 2y. Y multiply 3 means 3y. Plus z multiply 2 means 2z. Minus 1z. 1z. Correct? That means equals 1 minus 2, 5 vector equals, add these 3 vectors. First components add. First component. What is the first component here? X. What is the first component here? Y. What is the first component here? 2z. Add these 3. Correct? So we will get x plus y plus 2z. Comma. Second components add. X plus 2y minus z. Comma. Third components add. X plus 3y plus z. Correct? 1z means z. So what we got now? We got this vector equal to this vector, correct? This vector equal to this vector. These two vectors are equal sign you can see, correct? Now when we are telling two vectors are equal, first component should be same, second component should be same, third component should be same. So what is the first component you can see? What is the first component? Here 1, here x plus y plus 2z. So we can write x plus y plus 2z equal to 1, correct? First component equal, here 1 first component, here x plus y plus 2z, correct? Here 1, these two are equal. Now second component, x plus 2y minus z, x plus 2y minus z equals minus 2. Now third component, what are the third component? X plus 3y plus z, x plus 3y plus z equals, what is the third component here? 5. So we can write it is 5. So we got one system of equation now. How many equations are there? 3 equations. How many unknowns are there? We have 3 unknown, x value, y value, z value. 3 unknowns, we don't know that value, correct? So it is, we are calling a 3 by 3 system. What is we are calling? 3 by 3 system, because 3 equation and 3 unknown. From this 3 by 3 system, we need to calculate what is our x, what is our y, and what is our z. This is we are doing by using calculator. So just to go to the calculator, you can just press the mode button. After that, number 5 equation. Number 5 equation. After that, you can see one option, anx plus bny plus cnz equal to dn, correct? Because here we need to find 3 variables, x, y and z. That is why we are choosing anx, bny, cnz. That is number 2 in your calculator, number 2. So once you are clicking number 2, calculator is asking some numbers. Okay, these 3 equations behind the numbers we need to enter there. For example, first equation, x plus y plus 2z equal to 1. What are the behind number? You can check. What is the x behind number? 1. So you can press 1 equal to. After that, press equal to. Okay, then y behind number. What is y behind number? 1. Press equal to. Okay, after that, z behind number. What is that? 2. Press equal to. Right side number 1. Press equal to. Okay, like this continue in the second equation also. Second equation also same thing we are doing. What is second equation? X plus 2y minus z equal to minus 2. So what is x behind number? 1. So press 1 equal to. Okay, you can calculate same like this. So press 1 equal to. After that, y behind number 2. Press equal to. After that, z behind number minus 1. Don't forget that minus 1. Press equal to. Right side number minus 2. Correct? Then again go to the third equation. Same like go to the third equation. X plus 3y plus z equal to 5. So what is x behind the number? You can think 1. So press 1 equal to. After that, y behind the number 3. Press equal to. After that, z behind number 1. Press equals. After that, right side number 5. Then press equal to. After that, okay, 5. Press equal to. So calculator immediately showing your x number minus 6. Press equals, you will get y number 3. Press equals, you will get z number, that is 2. We will get the solution easily from the calculator. Okay. Now if you want to return back, same calculator mode, return. Okay. Press the mode button and 1. Mode 1, that is the normal computation mode. mod 1. Okay, so don't forget this step from calculator. Now see here we need to be careful, like here three variables are there, x, y and z. Okay, if it is two variable, you can use number 1 in the calculator. Instead of 2, you can use number 1 in calculator. Okay, so that you will get it. So I am writing here the values now. X value minus 6, y value 3, z value 2. If you are missing some numbers, answer will be different, so carefully enter. Now, so x number, y number, z number we got. So if you got y number, x number, z number, meaning is linear combination exists. Okay, we can write the linear combination, correct? Now we write the linear combination. See, this is the linear combination. V equal to x u1 plus y u2 plus z u3. So we are writing the answer, vector V equal x. X means minus 6. Multiply u1 vector plus y, that is 3. Multiply u2 vector plus z, that is 2. Multiply u3 vector. So this is the linear combination. Vector V as a linear combination of u1, u2 and u3. That means vector V, we are representing the vectors u1, u2 and u3 in terms of. Okay, that is the meaning, linear combination. So I hope this question can practice same like this. This is in space. Plain means vector V equal to x u1 plus y u2, only 2, correct? Here z also will come. So find x, y, z using calculator and apply there in the linear combination. I hope you understood this question. Okay. Now question number 8, the last question here. Question number 8. Is the vectors 2, minus 3, 4 and minus 4, 6, minus 8 are collinear or not? That is the question. Collinear. Collinear means they are coming on the same line, correct? So these two are collinear or not? That is the question. For example, first vector I am taking vector u. 2, minus 3 and 4. Second vector I am taking vector v. Vector v equals minus 4, 6, minus 8. Correct? Now, these two vectors collinear or not, how we are checking? You can see vector v. Vector v. See these three number, minus 4, 6, minus 8. Which number is common? This is the easier way to do. Which number is you can take it common. Minus 2 we can take it common. Correct? Write the remaining vector. What are the remaining vectors here? Remaining. See, for example, minus 2 taken out means minus 4, first number is minus 4, divided by common we are taken minus 2. So what will be balance? 2 balance, correct? So first number is 2, comma, second number 6. 6 we are taken minus 2 out already, so minus 3. So I can write minus 3. Third number is minus 8. We are taken already minus 2 out. So we are getting 4. Correct? So common number I took outside. Okay. So you can see correct or not. Minus 2 multiply 2 minus 4. Minus 2 multiply minus 3 6. Minus 2 multiply 4 minus 8. Now you can see what is this actually. Vector 2 minus 3 4. What is vector 2 minus 3 4? It is vector u. Correct? So what we can write? Vector v equals minus 2 multiply vector u. Yes or no? Because that is vector u, that vector 2 minus 3 4 means vector u. That means one vector equal to, minus 2 means a number, a scalar, correct? A number multiply the second vector. One vector equal to a number multiply the second vector. Means that two vectors we are telling collinear vector. Okay? One number multiply second vector. One of the vector, vector v or vector u equal to a number multiply the second vector. Means we are telling that two vectors are collinear vector. So these two are collinear here, these two vectors. Okay? Vector v equal to a number multiply second vector. Or otherwise what we can do, see, you just start with vector u equal to a number multiply vector v like this. Okay? A number multiply vector v. You can take the reverse also, no problem. That means vector v equal to a number k multiply vector u. Then you apply here vector v equal to k times vector u like this. Okay? For example, vector v. What is vector v? Minus 4, minus 6, minus 8. Minus 4, 6, minus 8. Equal to k times vector u. What is vector u? 2, minus 3, 4. 2, minus 3 and 4. After that here you can multiply k multiply 2, 2k, k multiply minus 3, minus 3k, k multiply 4, 4k, correct? Now this vector equal to next vector, this vector equal to this vector, correct? These two vectors are same. So first number should be same. What is the first number? Minus 4 equal to 2k. From here you will get what is the k number? Minus 4 over 2. You can divide both sides by 2. So what is k number we are getting? Minus 2. Are you getting? K equal to minus 2. That is the number we took here common, minus 2. Okay, minus 2. So little logic if you are applying, firstly we will get minus 2 multiply. Then here also check all the component, you need to check that k number same or different. Okay, 6 equal to minus 3k. Both side divide by minus 3. Here also you get k equal to minus 2. Third one, minus 8 equal to 4k. So here also you will get k equal to minus 2. See, all should be same, not different. Okay, so we will get the k number minus 2. So we can write, what we can write? Vector v equals a number, that is minus 2, multiply vector u. Okay, that means these two vectors are collinear. Like this also you can do, up to you only. So collinear, this is the idea, one vector equal to a scalar number multiply another vector. So I hope you understood the idea, all the ideas from this section, 1.1 section. We discussed almost all the idea questions, different questions. Okay, now you can practice some questions from that section. So thank you for watching this class. So please subscribe my channel for getting more recorded classes from other sections. Thank you very much.